Hello, today we are going to talk about the cycle you edit a QML file, you build, and then you run the application. How can you edit a QML file and make sure it's valid and it's what you want? Okay, we're exemplifying this using the application Tocodon. We have built using kdesrc-build Tocodon. So we have the latest source code from the upstream KDE Git repository for Tocodon, the master branch, and we have built this locally. We have run it by sourcing ~build/tocodon/prefix.sh and then running Tocodon. Okay, so this is how the application looks like. Now let's see how we can edit the QML and make sure we did not introduce any new issues. So a thing that we could do is just run Visual Studio Code in the directory where we git cloned the Git repository for Tocodon. And let's, for instance, edit a welcome to Tocodon string. Ctrl-Shift-F. Welcome to Tocodon. Okay, so these are the translations, the files that end with .po. So we're going to ignore all of these files to exclude *.po. So there's just one place where it remains in the login page.qml. Okay, welcome to Tocodon. We have edited this string. Okay. Now, how can we refresh the Tocodon application such that these settings, the new version of login page.qml is applied? Okay. First of all, we need to save. Then we're going to rebuild Tocodon. Let's close Tocodon. So the incantation using kdesrc-build would be kdesrc-build, the name of the module Tocodon, and then we don't want any git operations. Make it fast. Then we want to install in ~kd/usr. We'll see if we need this or not. So in order to make sure reinstall works, we would need to rebuild. So that would be refresh build. And then for bonus points, we're going to go debug. Okay, this thing, I guess, works. And I guess also, if we don't put --refresh build, it's still going to install in ~kd/usr/bin the new Tocodon executable. So let's look at the Tocodon executable. So it's in ~kd/usr/bin and then Tocodon. Okay, it's 13 megabytes in size. It's an ELF, so a x86 AMD 64 Linux binary. And why is it so huge? Because it contains the resources, the QML resources, and SVGs and other things. Okay. Let's look at its dependencies. So it depends on a large number of .so files from the Qt framework, from KDE, from my Linux distribution, C++, compiler, X11, compression, X, hardware acceleration, fonts, etc. Compression again. Okay. So let's run the new tocodon. In this tab, we have sourced the prefix, so we can start tocodon as many times as we want. And indeed, the text that we have edited has been applied in the application. So this is the slowest loop that I know of editing the QML file and then seeing the end result, which is the executable tocodon being started and run. Okay. Okay, let's put a, I don't know, a 2 in here. Let's see if not doing refresh build is enough. We see that if we did the refresh build, it writes the up-to-date files into tilde/kd/usr, it rewrites those, and then it writes the new files. Okay, so let's see what happens if we don't go refresh build, because this will not go rebuild, so it will build. So only the affected files will be actually compiled, not all of the C++ files from scratch. So this might be a bit faster. Okay, it immediately jumped to 100%. The compiler went the make steps, or make -J16 went 4%, and then 59, and then it jumped straight to 95%. Okay, but then it says that it didn't do any make install. Okay, so let's confirm it did not do make install. Yeah, so it did not do make install. So the only way to do the slow method is to edit, then build using the only command line that works, which is, which are you? This thing. Okay. And if you want to automate that thing, that would be something like and not end, but semicolon to start tocodon. But we want to start tocodon in another tab. So how do we do that? Let's see if this works. So we're in the tab where we did source the prefix file. Let's see if in here we run this long command line, it does what we want, which is build, install, and then run. So the 3 steps in just one command line. Okay, building takes longer because it rebuilds every CPP file from scratch, but it's plenty fast on my machine. Okay, and it says 2. So this command line does these steps, so you can have the text editor where you edit QML. You have a console tab where you run this long command, and the command should have a ampersand at the end. Okay, so Control ZBG, this thing. Okay, is there any faster way for us to edit just this part of the QML and make sure it's valid? Okay, so let's see how we do that. There's a way to run straight a QML file. Okay, so we edited the login page. We go Control backtick, and where are we? So it opens the terminal not in the directory where the file is, but in the top level directory of the Git repository. Okay, that's disappointing. Let's open a new console tab. Let's go to the source code. Okay, and then go to the place where the file is. So we're editing this file. And Alt backspace to delete the... So this is the full path to the file. We have deleted the file, so now the full path to the containing directory remained. Okay. The executable is called qmlscene. Doesn't have a manual. It does have a help. So let's look at the help. So it says qmlscene and then a file that has the extension QML. Maximized, full screen, transparent, multi-sample, core profile. If you don't want a GL, slow animations, resize to root. Quit immediately after starting. Desktop, GL, GLES, software rendering, high DPI, default is widgets, text render type, tutor native, additional paths for the plugin paths and for the plugins and for imports and translation file. Okay, so let's go qmlscene. We don't need any of these parameters yet, and then the name of the file, which is login page. Okay, it says that or KD Kirigami add-ons labs mobile form is not installed, or KD Kmasto is not installed, or KD Kirigami add-ons .labs is not installed, and then again or KD Kmasto. So I guess that this thing comes from the only place where it could come, which is tilde/kd/usr, while this comes from this Git repository, from the Git repository of Tocodon. So let's fix the fact that qmlscene doesn't know how to search in tilde/kd/usr. We're going to run the prefix. So source tilde/kde/build Tocodon prefix, and then run again qmlscene. And now it only says that there's just one error, that it doesn't know what or KD Kmasto is. Okay, what's that thing? It says or KD Kmasto 1.0. How about we just comment out this thing? So this is taken from KD source code, from Kirigami add-ons. So from tilde/kd/usr. These are from Qt, so /usr. This is from Kirigami, which is a KD framework, which is from tilde/kd/usr. The problem is with the source code that's in this Git repository in Tocodon. So just this I have commented out. Ctrl S. And now it does something because I have this icon in my icons only taskbar, but it's really small. Maximize. Okay, I don't know how to maximize it. Why don't we see it? let's specify that it should be maximized. Okay, so we're here. There are some things that we can edit and see, some other things we cannot edit and see. Okay, let me save a bit what we did. So this, and we require sourcing both in this code path and in this code path. Where are you? Copy path. Change directory and delete the name of the file. Okay. Okay, so we sourced, we changed to the directory where the QML file is. We went qmlscene maximized, and in here we went comment out in the QML file all of the lines that this thing. Okay, so where are we? We cannot see the strings. Why can't we see the strings? Because the strings are under the function internationalization, and that's it. If you really want to see the string, you will need to remove probably the function. Control S, and then we have the problem that after saving the QML file, qmlscene doesn't refresh automatically. So we need to prepare a command line that restarts qmlscene. Title login. Yay, we have text. So the master page, we don't know what it is. It's probably defined in here in our KDK master. That's why we don't see the title login. But then it understood what a column layout is, and Kirigami units and large spacing and Kirigami themes. Okay, so the only thing that actually does not work in this case, in this file, is instead of master page uses some other cute QML type, and AI, the internationalization function IAITN does not work. But it's not a problem, because what you actually most of the time really want to do in the QML file is layout things, or sometimes you have the need to see how the QML file works if you have a very large, very long text in here. Control C, V, Control S. Okay, and it works correctly. I'm not sure if it works correctly. Okay, it works correctly. Okay. It resizes correctly. Okay, or maybe you want to change a color or a style or a CSS thing, you know, to design. And in this case, it's enough. This would be enough for that use case where you just play with the box model and the colors and rounded corners and CSS stuff. Okay. How do we change a color? Can we do that? QML background color. Background rectangle. Palette button green. Material background, material red. I totally don't know what this thing does do. So do we have a rectangle in here? We have mobile forms and color steel blue. Yes, to that. Cannot assign non-existent property color. Just a second. Okay, so I have just pasted these rectangles. And sure enough, the rectangles appear. So yes, you cannot use this technique to do everything. You can't use bindings, model views, etc. But for some parts of the QML work correctly when run under qmlscene. You can edit and see them, how they change. So not 100% of the QML file works, but I know 80% of it does work. So some of the things that you would want to edit in a QML page are part of those 80%, and it's enough if you just open the file using qmlscene. So edit the QML file and then qmlscene, or edit the file qmlscene again and again and again. Okay. So why is this faster? Because maybe you don't, so if you, yes, if you want to edit the QML page login page.qml, then this takes, we refresh build, I don't know, 10 seconds, and this takes less than 1 second. So the difference is not that big, it's just 9 extra seconds for the slower loop. But if you try to edit a QML page that's visible under only such and such and such circumstances, so only if you're logged in to Tocodon, only if you have ever posted tooted, you know, only when you're reading the local timeline, only when, you know, and it takes 10 minutes to click around in Tocodon to arrive at the place where you can see that QML page, then just opening that file, that QML file directly using QMlscene is infinitely faster. Okay, I know, the Sonnet card or something. Tooth Composer. How do you get to the Tooth Composer without actually having a Mastodon account, actually starting Tocodon, choosing to log in, and then starting to compose a tooth? No? Sometimes just running the application to get to the place where you want to verify takes a ton of time and a ton of manual steps, like you need to click and enter passwords and enter license keys, etc. Let's see if other pages work correctly under QMlscene. Let's see the Tooth Composer. Okay, Tooth Composer, where are you? Says line 168, Control G, 168. Expected colon. Why doesn't it have a colon? Right, why? Should have, right? So after text should be a colon and then the internationalization function. Okay, so that was a bug that we just found. So just running with QMlscene all of the files is a kind of linting the files, right? Okay, so line 10 is the problem. So this is from /usr, from /kd/usr, and this from /usr. Control S. Attachment editor model is not a type. What is that? Yeah, it has a model. What can we do with models? Okay, and we have takeoff. So just by running in QMlscene a random QML file, we actually have identified a thing that looks like a possible bug, so a missing colon. And we can see 80% of the page. So we cannot see the model because that's from C++, and we actually don't load any .so file from the Tocodon KDE Git repository. We didn't even build the C++ code. So you just git clone Tocodon, you don't build the source code not even once. You ignore all of the CPP and .h files, and you just look at the .qml files. And 80% of those, maybe more, can be run under QMlscene if you comment out the parts where the QML file wants to receive things from QML or to send things to receive things from the C++ source code and to send things to the C++ source code. Okay, because we just did not even build the C++ code, source code yet. So qmlscene starts fast and has 80% of the QML components and properties and everything working correctly. Styles, themes, etc. Okay. And now the third part that we want to touch is the KDAB's gammaray. Since I'm using Qt from /usr, so from my Linux distribution Ubuntu 22.10, I can use gammaray from my Linux distribution. Okay, it's already installed. Let's start first qmlscene and see if this thing is inspectable using gammaray. Okay. Where is qmlscene? This thing attached to it. Okay, so widgets, there's no widgets in here. No remote view available. There's a QDesktop widget and a QDesktop screen widget. Okay. Then for Qt Quick, there's quick scenes. Okay. So this would be everything that's not so everything that's not kwin. So the kwin would be the server-side decorations. So the application title bar and the shadow and the margins of this window. But the rest is a thing which is called the Qt Quick root item. And inside we have a Qt Composer, a scroll view, a overlay Qt Quick item, a busy indicator, action buttons, and a rectangle. And the rectangle has an image. Okay. Let's see how we pick elements. So with the picker, cancel. There's a scene graph. There's matrices. Okay. So let's look at the attach button. So the attach button is a quick style item. This is an actions toolbar. This is a tool button. So the tool button would be the attach button. Okay, does it have text? Text beside icon. No text. Let's put some text in here. Attach a file Please. Okay. So to a live running application, we can read a ton of things from that application, and we can write to that application. So in this case, we wrote the text property of the QML tool button for attaching files. Okay, and there's a richness of things that you can read from this small qmlscene application. Validator. What else? Live events. Delete, shift delete, toggle places panel. What are these? Actions for what? I don't know what these things are. Okay, messages. So this would be the QDebug. Because they have a category. I guess, I don't know. Meta objects. So QML objects are Qt objects, so they use meta objects, and they have rich runtime inspectable properties, attached properties, methods, events, slots, etc. Okay. Meta types. Objects. What are these objects? So this is another hierarchy of objects. We're at the tool button for attach, which is a QML type, and this object has a ton of children. There's a file dialog, there's style, there's okay, so gammaray gives you a richness of information about the application that you're running. You can change a ton of things. I don't know how to do that besides editing text. I'm sure you can change many things which are related to styles, such as colors and paddings and CSS and textures and who knows what else. As a last resort, use this to inspect why your QML file does not look the way you like it, why it doesn't lay out the controls the way you want. Okay, so that was how to, when you edit a QML file using a text editor such as Kate, you don't have many tools at your disposal. You don't have a GUI editor. You don't have a linter. You don't have validation. You don't have strong typing, compiler errors and warnings. You don't really know what's allowed and what's not allowed. Plenty of Git commits have been made with invalid QML files, right? So it's really important that then before redoing a Git commit, you test your changes. So either the slow way, but this thing works anytime and using any text editor, or the QML scene way, which is faster, but then you're not seeing the entire picture. You're seeing just 80% of just one file. You're not seeing active bindings and things that come from the C++ source code models and view models, etc. Okay, and do learn gammaray, how gammaray can read and write to QML applications. Okay, let's see if we run the real application, what happens. And do not fear if the gammaray application crashes. You just reopen it and that's it. You're going to start from scratch. What are these? Why is there a course tag for the messages? I don't know. Okay, so gammaray has crashed, not a problem. You open gammaray again, and then the next time you don't click on the button that causes the problem. Okay, so just a second. I have built Tocodon using kdesrc-build successfully. Let's see if the source code is up to date. So in tilde/kd/src tocodon git fetch origin, git GUI, extra sure. Where are you? Fetch from origin. Visualize all branch history. So both the local master branch and the remote origin master branch is point at the same git commit, which is run clang format. Okay, let's now run Tocodon. So kdesrc-run Tocodon. Okay, and the thing crashes. Tocodon closed unexpectedly. Please report this error to help improve this software. And it enters a special place where it refuses to shut down. So the process continues to run. Okay, so the process Tocodon is this guy. So let's kill it. Okay, so Tocodon has closed. Now what can we do? Why did it crash? If this were a interpreted programming language, it would say a call stack where the problem is, but it's not. It's C++ plus QML. If this were Java or C# or some garbage collected programming language that's memory managed and has a runtime environment. Again, it would throw an exception and we would see what's happening. But in this case, it crashed with this assertion in qlist.h in Qt, and then kcrash and Dr. Conky started. Okay, so what can we do in order to see exactly what crashes? So for now, we just know this is empty in qlist. Okay, the first thing that we can do is just run kdesrc-run tocodon in the debugger. So that's gdb, and then the rest of the command line. The first thing that we tell gdb to do is run. No executable file specified. Okay. kdesrc-run tocodon. Okay, let's source the prefix then. So tilde/kd/build tocodon prefix. Now we can see if we can reproduce. Yes, it crashed again. We need to kill it again. And let's see. So it crashes, but do we still have a tocodon process or not? So there's a Dr. Conky, there's a tocodon, another Dr. Conky, and then a grep. So I guess I still need to kill all tocodons. Okay. Now let's run it in the debugger gdb. Okay. Run. It says, do you want debug info D? And we do not want it because the KD software source code is built using kdesrc-build, and we don't really need debug symbols for Qt. So press enter, which select the default value, which is not. Do not use debug info D. Application starts running and it immediately crashes, says thread 1 tocodon received signal sig abort, aborted. And now we can do the normal procedure that we do using gdb. So that would be, are you? KD wiki gdb. What was that thing? Good stack trace. Okay. Without the debug info D, we don't need any symbols because we already have them. So it crashes. And then what do we do? Generate backtrace. So we go backtrace full. Let's actually do this procedure where we save. Set trace commands on. Ctrl+Shift+V. Set login override on. Set pagination 0. Okay, so it generates the backtrace all with debug symbols, locals, parameter values, everything for the current thread. We look at the CPU registers. We look at the local variables in the function that's topmost in the core stack in the current thread. And then backtrace for all of the threads. Okay, and then we can exit. Quit anyway, yes. And now let's look at what we collected. This file. Okay. Language. What did I use? Doesn't matter what language I select. Okay, so backtrace full. Says pthread kill implementation. Pthread kill, this is in nptl. Okay. And then we're at qmlscene fatal, and then qtassert. We saw the text from qtassert and the message log. Where did we see that thing? So if we start tocodon in here, it says assert is empty in qlist.h. So that's qtassert from qlist first. Line 361, so this thing, line 361. qlist method first. And assert is empty is asserted by qtassert and written to standard output by qmessage local fatal. Okay. So the problem actually is in a timeline model, fetch timeline file timeline model.cpp line 78. Okay, let's kill all again. So this is the way we can generate the call stack using GDB, which is way better than just looking at the assert qmessage local logger fatal. Okay, but we can do even better than this. We can run this thing in Qt Creator, the ID. Okay, so I've installed Qt Creator ID from the Qt website, so it's the latest version. Let's open it. This is the source directory where where kdesrc-build has git cloned tocodon. File, open file or project, Ctrl V, cmake lists.txt. Projects, manage kits, remove under manual everything that's not italic desktop default. Remove, apply OK. Import existing build, paste, replace src with a build. Go. Manage kits should be just 2 kits. OK. Debug2 was created correctly. Now we can run cmake we can build, but we cannot run this thing because we didn't run prefix.sh. So let's see how that thing looks like. In projects, build and run, imported kit, run, we select run settings, run configuration to be Tocodon, so the GUI application, not a test executable. And then we go run. Okay, so it did work. Why did it work? It says use build environment. And I have I don't have all of the needed environment variables set. But somehow it worked for me. Okay, I don't know why it works, but how it should work is as follows. In projects, build and run, imported kit, run. After you select Tocodon, you need to set the environment variable. So for that, you go environment. It's okay to use the build environment, but then we want to make all of the settings that exist in the prefix file. Okay, so we want to make all of these settings visible here in the list of environment variables. So we want, for instance, xdg data dirs to start with tilde /kd/usr/share, which they don't. xdg config dirs also start with the incorrect directory, so we'll need to edit all of these environment variables. How we do that? There's two options. Either we click, for instance, xdg config dirs, we click in here, and then we prepend manually what we want. But a better alternative is to go batch edit, and then put all of these things in here, but using this syntax. So not the bash syntax, but the Qt creator syntax. Okay, so for that we copy everything, Control N in Kate, Control V, and then this line should not have an export space at the start. Okay. The commented outlines should not exist, the empty lines should not exist, and then this thing actually prepends to the existing path environment variable this directory. This sets this directory prepended to this directory, but then it removes this directory. I know. Okay. So the syntax for prepending is this thing. To prepend to a variable, use variable equals plus value. So let's do that. All of these instructions are actually prepend. So we need to replace all of the equals with equals plus. To prepend equals plus. Replace all. And then we don't need whatever is after the colon. So we don't need any of this. Okay, because why would we need this when we say that Qt Creator will prepend this thing to the existing environment variable path? That's what plus equals plus to prepend the variable does. Okay. So for this, in Kate, we switch from mode plain text to mode regular expression, and we tell it to replace colon and then any character any number of times with nothing, and we go find first, find all, so it selected everything after the colon, and then we go replace all. Okay, we copy this thing and we paste it in the edit environment Qt Creator. Okay, so that's how it should like. The default build environment plus batch edited these things. They will be shown in here, so it says use build environment, but prepended this directory to the environment variable path, this directory to the environment variable QML to import plugin, etc. And the environment variables shown in normal black are from the build environment. The ones shown in blue are the build environment plus the prepend actions. Okay, so let's run it again. Okay, let's close this thing. And now the next thing to do is to just run this thing in the debugger in Qt Creator. So let's start the debugger. Let's delete all of the breakpoints. Yes. Let's stop the debugger, and then let's start the debugger again. Okay, and it says that it has caught sig abort. Yes, GDB caught this thing. I go OK, and now it says that at least on qlist.h line 361 there's a problem in here. So qassert is a macro. Okay, so let's look at the call stack. Where are you? It's the same call stack that we know. Where was it? Close it. So it's qlist first, then qtassert, then qmessage logger fatal. We don't have the CPP source code to Qt. We've installed Qt from using the Linux distribution that I'm on, so Ubuntu 22.10. And fetch timeline is actually from Tocodon. So we have the source code for everything that's KDE, so KDE frameworks, other libraries, and then the source code of the project that's currently open in Qt Creator, which is Tocodon, the Mastodon client from the KDE community. Okay, so this is the problem, this line. And then there's an operator, and then okay, so field timeline is the problem. Okay, this is in the C++ standard. Same place. Same place. C++ standard. Account is in Tocodon. And then we're in Qt. Okay, so I've put some breakpoints. One on the line where the problem is, on the line where the problem is, and at the start of the method field timeline. We can see the method field timeline at positions 11 and 12 in the call stack. Okay, let's stop the debugger and start the debugger. And we keep starting the debugger because we don't use a reverse debugger. We cannot step back in time using the debugger. Okay. So let's see what happens. So it says from ID, and then it says if there's no current account and there's none, M account is 0, then it returns. So that's the problem. Or not. I'm not sure. What is the reply? QNetwork reply. So this is an anonymous function closure. Callback or something. What is reply? QNetwork reply HTTP impl. I don't know. Okay, so the second time field timeline has run is still okay. Now we've entered the method field timeline the third time. Timeline name is home. Posts is empty, so for the home timeline, posts is empty. This is because fetch timeline has an empty data array. Functional programming. And then it crashes. So when it gets the timeline home, it's when the problem occurs. Let's start again. So what's the name of the timeline is the empty string. The second time the name of the name of the timeline is empty. Back. So we need to put a breakpoint in here. So from ID does not matter. What matters is the timeline name, which is home the first time. The second time it's home. Zero posts and first crashes. Okay, I don't know how to how to identify this issue for now, but I have shown what we do when Tocodon crashes. Tocodon is an application that uses QML for the front end, for the graphical user interface, and C++ for the business logic models, etc. And it crashes. We can reproduce it each time. We use the application build from using kdesrc-build, using the latest source code from the upstream Git repository, from the master branch. And we can see the crash in 3 ways. So if we just run it, the application, it crashes and we see just the assert, and then the fact that here crash and Dr. Conky start. If we run it using the debugger, we get this report. So this is the call stack locals. So these are the local variables in this function. These are the value of parameters. This is the signature of the functions in the call stack. We have this thing for the thread where it crashed, which is the main UI thread, the first thread. And then there's additional information like registers and a shorter stack trace without locals for the rest of the threads, the rest of the 23 threads. Okay. And then we have run in the Qt Creator IDs debugger the application, but we needed to set these environment variables in projects build and run imported kit run, and we selected tocodon and we append it to the build environment. We prepended to some of the environment variables values, so to 6 environment variables. Okay, and then just running the application in the debugger has stopped at the correct place because Qt Creator's ID's debugger implementation actually is a wrapper on top of GDB. GDB senses that the application crashes, and Qt Creator tells us about this thing.